Hello, welcome to the show. It is me, John Park, and it is time for JP's product pick of the week. I just had my lower third turned off. Got it on. Woo! Freaking me out. Hello and welcome to the show. Thanks for coming, and I'm sorry about the mess, first of all. Messier than usual. And the delay. In fact, I'm going to go turn off one of the sources of the delays, which was some electrical work going on in here, including getting that vent fan on a switch there. That'll allow me to turn that off during the show. So what have we got today? I've got an exciting and excellent new product pick for you, a big discount on it. Before we go any further, I'll tell you this is the place to go if you want to jump inside of the product page. Join me because I'm broadcasting from right there inside the product page. You can just go to that QR code or that URL right there. That'll take you to the same place, which is the product page. Scroll down a bit and you'll see this video playing right in there. The discount, I believe it's a 50% off this week, is good just during the show. You don't need a coupon code or anything like that. You just want to throw it in your cart and check out before the end of the show because we just drop the price during the show and then bring it back up afterwards. You can get up to 10 of them, no resellers allowed, and you might want to pick up some other related stuff, which I'll reveal in a second here. But before I go any further, let's have Lady Ada tell us all about this week's product pick. Take it away, Lady Ada.
Next up, this is something that we're using for internal hacking, but I thought I would make a dev board for it so other people could hack with it. It's a piezo driver using the PAM8904. This is a chip that's specifically designed for driving piezo discs. And what's interesting is that it seems like the audio amplifier, it can go up to 300 kilohertz, which is not something you can do with, maybe it's 100 kilohertz. I can't remember, but it's like more than 20 kilohertz of piezo discs. So it's good for ultrasonic and like other like non-audio based piezo driving needs. Sometimes you have to like vibrate something or you want to like bounce ultrasonic waves off of something. A piezo will do that, whereas a speaker will be too slow. So this is a driver that takes in 3 to 5 volts, or 2.5 to 3 to 5 volts, and it will use 2 internal switch cap converters to give you up to 3 times gain on the voltage, and then it uses differential output. So if you have 3.3 volts in and you have 3.3 times gain, it'll give you 10 volts output, and then differentially, because it's like plus or minus, you'll get 20 volts across the piezo. So much stronger drives, especially we needed this for doing ultrasonic experimentation where you can't just drive it from my controller pan and get, 3 volts, 20 milliamps output. You want something much stronger. There's a little gain setting at the top. Both are off. It's, if both are set to off, then the sensor's in sleep mode, or the driver's in sleep mode. 1 gain, 2 gain, both to the right is 3 gain. Only thing to watch out for is don't set it to 3 gain if you're using 4 volts or higher, because the output really doesn't want to be more than 10 volts peak to peak. And while I wish they wouldn't let you purposefully destroy the sensor, and you're not going to destroy it instantly, it's not good for the sensor to be strained. So if you're at 5 volts, keep it to 1 or 2 gains so you don't go above 10 volts.
That is excellent advice. So look, there it is right there. Look at this little cute guy. This right here, that is my product pick of the week this week. It is the piezo driver amp with the PAM8904. Is that your name? What's your name? Yeah. It is the piezo driver amp with stemma, and it drives the, let me say that again. It is the piezo driver amp, stemma, PAM8904. So this has a 3-pin stemma. Remember, stemma can be stemma 4-pin, stemma 4-pin QT, the small one, or it can be this stemma JST PH 3-pin, which allows you to plug it into power, ground, and signal on your board. And then we also have terminal blocks right here for your piezo elements. So here's a typical piezo buzzer. And you can drive these from a microcontroller by setting a PWM signal, but it is not going to be super loud, at least not compared to this. This will give us all the way up to the peak to peak, I think 10 volt, or is it 20 volt peak to 13 volt? Sorry, it's a 13 volt peak to peak that we can drive safely. And this can be driven off of either the 3 volt 3v3 or the 5 volt on your microcontroller. And then, like Lady has said, we have some dip switches there to adjust the gain on that, so you can boost that up quite a bit. So let me do a little demo here. I'm going to switch over to a view here, and actually, no, wait. Let me show you putting this together. Let's pull that view out of there. So before I actually zoom out, I'll show you here are the little gain switches. So I have this set to 3x gain right now. You can go to 2x gain at most if you're using 5 volts, but we can go all the way up to 3x gain, and this would be 1x. And somewhat conveniently, you can go to 0, and that will actually mute the thing, which is kind of nice to have that just built in there. But I'll leave this up at full blast, and I'm driving this with 3 volts, so that's safe to do. And I'll come out just a little bit here and refocus for you. I don't like to use the autofocus. I like to, there we go. So this actually is a AC element, and so it doesn't really matter which wire gets plugged in where. It's not a DC thing like some speakers. So what we'll do is tighten those leads down on that piezo element. This is the large piezo element that we sell in the Adafruit store, and I can show you a link to that in a second. You can also run it with the little small one. I've got a project with that on it right now. Okay, so those are in there good and snug. And then you can see here we have a 3-pin JST, and we have versions of these that terminate in a variety of ends. We've got alligator clips on them, male header pins, female header sockets. I'm using the male header pins and plugging that into a Metro RP2040 there. And you can see I've got my 3-volt power, ground, and then I'm running off of pin D5 there. It's kind of hard to tell which one it isn't exactly. So I'll zoom out here a bit and give power to the Metro. It's going to do a little reboot. So you should be able to hear that pretty well, even though it's my mic is a little further away. I'm going to bring that up close. And what I'll do is actually quiet this thing a bit. So that's the 1x gain, and that'll turn it off, even though it's still running. That'll essentially mute the thing. And let's take a look at the code that runs that. So here you can see I've got kind of a complicated example. You can just straight up send PWM 50% duty cycle, send it frequencies, make some noise. In fact, if you look in my code window, that's this simple example down here. So this is a typical one: piezo duty cycle, sleep, set the duty cycle to 0, pause between notes. That'll just buzz it on and off. But what I'm doing is actually I made up a neat little example here using an arpeggiator, and this is Todd Bott's ARPI library that he wrote, and I'm able to send it the same sort of thing. I'm sending it a note on message, and that will run this right here. Piezo frequency is whatever the frequency the library is telling it, and the duty cycle is set to 50%. And then on a note off message, I'm setting the duty cycle to 0. So the rest of this is all just ARPI stuff. If you look in Todd Bott's SynthIO examples, even though I'm not using SynthIO here, I was able to grab this utility, which is kind of cool. If you want to, you can use the simple IO tone to run this. You can use straight up PWM tone generation, and I'll show you in a second some examples of that code on the site. But actually, since I said site, that is the page right there, and you can see there's the device for $2.48. If you look over on the right underneath this Add to Cart button, you'll see we have some links to some JST 3-pin cables you could use, either the female socket or male header, similar to what I have there in my example, or the alligator clip version. And also here's a large enclosed piezo element with wires. That's the same one I'm using right here. If you scroll down a bit, you will see a link to the Learn Guide, which is this right here. And this will tell you all about it, how to run it, how to set up the code for it. There's some code examples. There are pinouts right here, so you can see V-in. You can run that anywhere actually from 2.3 to 5 volts. If you're running off a microcontroller, typically you'll just go with the 3V3. And then the signal pins. Now you don't have to use the JST connector. You could solder to the little pads that you see on the bottom there, or solder some header pins and stick it into a breadboard or a perma-proto board. And you'll see here this pin signal. That's where you provide your square wave, and that can be anywhere from 20 hertz, which is basically at the bottom of the scale of human hearing. 20 hertz all the way up to 300,000 hertz. So that is well beyond hearing range. I can, as an aging human, I can hear somewhere in the probably 13,000 range. I don't know how high up to go before my dogs hate me, but 300,000, that's in the ultrasonic range. So you can use this, like Lady Ada said, for experimentation with ultrasonic sensing. If you want to set up a receiver, experiment with things that can hear the reflected ultrasonic wave come off of a surface, that's a reason you might want to go up that high. But audible range up to 20,000 is pretty much it for a young set of ears. And if you look at, this will describe some things about the gain, as well as not using the 5 volt at 3x gain, because that's going to bring it up to 15 volt, which is more than this can handle. Then if you look, there are some examples for CircuitPython and Arduino. So if we look at this CircuitPython example right here, this shows wiring. And then in this code example right here, highlighting, you can see the setup is import time, import board for pin definitions, import the PWM-IO library, and then we set up the object. Piezo is PWM-IO.PWM-out, and then you give it a pin, in this case board D5. Tell it the duty cycle, which at 0 it's not ever on, right? It's a flat line at 0. Then the frequency, in this case it's being set to 440 hertz, and allowing it to do variable frequency by saying variable frequency true. Then in the main loop there, you can see there's some preset, a little melody has been set up there. The piezo frequency is changing and the duty cycle is going on. In fact, let's run this example. So I'm just going to hit copy code right here. Now we'll go back to my board. I'm going to turn the sound back up on that. Let's come over to my code window. And that should work, so I'm going to hit save. And it's just going to loop that forever and ever and ever. I'll resave the old code, go back up to this. One other thing I wanted to do that's just kind of fun is I have a, let me zoom out here. I have a piezo-based Eurorack module that can be used sort of as a type of a microphone for tapping on it and things, and it's actually pretty nice to do piezo directly to piezo and then be able to amplify that, send that signal through some sound processing and so forth. So if you take a look right here, this is the ears module based on Tom Whitwell's Microphony module. This was the Mutable Instruments variation on that module. And so there's a piezo element built under here used, you can see it's noticing that I'm tapping it. So that'll notice the vibrations of this. So what I'll go ahead and do is turn my piezo gain back up. And then I'm going to press it against this and we should hear it coming through. And so now we're getting a amplified and processed signal. Amplified, and now, oops, just give it some reverb. Turn that back down. So you can do a lot with these little beeps. They don't have to just be simple indicator type of beeps. They can actually be used musically if you run them through some processing. It's not bad. But one thing they actually really excel at is things like indication alerts. It's very easy to make this sound like your fire alarm or smoke detector going off. I'm using one in my B&O055 based power washer, pressure washer for the power wash simulator, because there are some calibration steps where I want to let the user know the status. And so I'm using one of these little amps here, as well as the smaller piezo element stuffed inside so that it's loud enough to be heard, which is a good use for these. So you can find a lot of uses for them. Let's see, what else? What am I forgetting? So, go back to this page here for a moment. If you look at the main page and scroll down a bit, you'll see here are 3 different piezo elements that we sell. I've tried the small one and the large one that have the wires on them. I haven't tried this this one that's got the breadboard-friendly legs on it, but I imagine that would work as well. So you can check those out. Those are options. I think that might be it as far as piezos that we sell that are designed for this type of use. And let's see, any questions that we have in the chat? Let me go check out the YouTube chat. Let's see. Yeah, 25,000 hertz, John Lupton says, for ultrasonic dog trainers. Okay, yeah, so we could, you could potentially do some dog training using this amplifier. By the way, I've got it plugged into a Metro here just because it was convenient, but you can imagine if you use something like Cutie Pie, you can get a pretty small little package there, maybe a battery and a little Cutie Pie, and you can make a nice little piezo object there. Let's see, other questions. Ken Wilson asks, and I don't know the answer to this, how would you sense the return from the ultrasonic? Now, we sell some devices that are designed for this, and they have the sender and the receiver, so you may want to look at those. This would be more if you're interested in experimenting with it, and then it's beyond anything I've tried, so I'm not sure. And if anyone in the chat knows, I'm not sure what type of element you would use. I don't know if it's also a piezo or a microphone instead that can detect that very high frequency reflected sound. That's an excellent question. Maybe ask that on Ask an Engineer tomorrow night, Wednesday. Ask an Engineer, maybe see if that's something Lamore can talk to. It'd be kind of interesting. Let's see. I think that does it. What have I forgotten anything? This once again, there is your picture there. There is the URL if you want to use the QR code or just type in this URL. It's product ID 5791. And you can see a nice close-up there of the boards. There is a, by the way, I should mention also a nice little indicator LED. Can you see that? You see that green? It's hard to see on the camera. I'll block it with my finger. There's a little green LED lit up there to let you know when you've got power to the board. Anything else? Any other questions? Thanks for stopping by. Don't forget to check out before the end of the show because the price is going to go back up. But I think that's going to do it. So here, I'll compete with these beautiful sounds here. And that is it. That is my product pick of the week. This week it is the Stemma Piezo Driver PAM8904. That is going to do it for this week's product pick of the week. Thanks so much, everyone. For Adafruit Industries, I'm John Park, and I will see you next time. Bye-bye.